Now, I'd like to show you that a large family of ODE can be transformed to Bessel equation. And we're going to show you two examples. And for the next week's homework problem, we're going to have 5 problems, very similar to what I described. Here is the first example. If we look at the given equation at the top, this is not a Bessel equation. Even we divide every term by 9, the first 2 terms may look like Bessel, but the last term, if we divide 36 by 9, we get a 4. But based on the definition of Bessel, this coefficient has to be 1. So the given equation is not a Bessel. We are advised to use this transformation rule, z equal to x squared, to convert this equation to a new equation that involves only z and y. So let's begin. We first look at the last term. The last term involves x to the 4th power. We can convert x to the 4th power by z squared. So this is a term which can be easily converted. Then if we look at the term in the middle, 9xy prime, we need a y prime. Y prime in this expression means the derivative of y with respect to x, but the new equation will allow us to have z only. For the derivative of y, it will allow only dy dz. Therefore, in order to make both sides equivalent, we have to activate the chain rule by adding one factor, dz dx. And dz dx can be obtained by using the given transformation rule, which is 2x. Then we can take care of the whole second term, 9xy prime. 9xy prime is 9 times square root of z times 2 times square root of z, that's this term, times y prime. This y prime is dy dz. Then we can move into the leading term. The leading term involves second order derivative. Second order derivative means the derivative of the first order derivative with respect to x in the given equation. Then dy dx is something we already obtained. That's in this form. So we can move into here. But the second order derivative means we want to eliminate this x by dz dx. This is also from chain rule, because in the new expression, we allow the derivative with respect to z only. So we have to add this new factor. Then this factor is not difficult. We can take the derivative of the given transformation formula. We get this expression, 2x. Then after we expand this derivative by using product rule, we get these 2 terms. Then eliminate this x by z, expanded, clean up, we get 4z y double prime plus to y prime. That's for the second order derivative. Then we have to put a 9x squared before it. Then we get these two terms. Combine these three underlined terms, we get this term, and then rearrange by dividing every term by 36, we get this expression. And we note at this moment, this is a Bessel equation. And the solution of this equation has to be Bessel functions. And specifically, Bessel function of the first kind of order 2/3. We don't need Bessel function of the second kind because this 2/3 is not an integer. After we get this solution for the new equation, we have to eliminate z. We have to transform z back to the coordinate for the first, to the given equation. That is, we have to replace z by x squared. So we get the very last equation. Then let's look at the second example. The second example is in xy domain. It's not a Bessel. By simply look at the first and the second term, if we divide every term by 1, second term is not 1. The third term, the constant before is 1/16. So the advice to us is to use two transformation formula. We have to use the transformation rule like this: transform the independent variable x to z by z equal to 4th root of x, y equal to z times u. Notice z is going to be the new dependent variable. This is the dependent variable of the given equation. This is the new independent variable. So that means we have to transform the equation from xy domain to z u domain. So let's begin. If we look at the last term of the given equation is relatively easy because this appears to be x squared. Square root of x means z squared. So I didn't put it right here. But we do need a y prime. Y prime in the given equation means dy dx. But the new equation allows only the derivative of u with respect to z. Therefore, we have to activate the chain rule for both the dependent variable u and the independent variable z. So make sure we can get this expression. It's nothing but chain rule by replacing the new dependent variable and the independent variable by the transformation rules. And then we have to take care of one term at a time. For the independent variable z and x, we can use this given transformation variable to get this derivative. After we get this expression, we eliminate x by z. And the derivative of y with respect to u, we can use this given equation, just replace y by z times u here. U is allowed, but then we have to take the product rule to get two terms. Notice for the first term, we keep u constant and keep z constant and take the derivative of u with respect to u. We got 1. And for the second term, we take the derivative of z with respect to u times u. That's this term. This derivative can be written as the inverse of u prime. And then we put all the information into this equation, we get this expression. And then combine 1/2 times x times y prime by substituting y prime in here, replace x by z fourth power. We get this expression, equation 7. Then we have to get the second order derivative. Second order derivative again means the derivative of the first order derivative. First order derivative is something we already obtained right here in equation 6. So just leave there. But these derivatives have to be converted to a operator that involves z only. This can be achieved by using chain rule again. This is the decided derivative with respect to z. So in order to eliminate z, we put an extra factor dz dx. dz dx can be obtained by using this given formula. So after we take the derivative of this term, as you can tell, we can use product rule to take derivative of term by term. We got 4 terms, then multiply what we have here into the derivative. Then we further have to modify x squared. The given equation has an x squared factor in there. So multiply the second order derivative by x squared, we get this term. The very last term is written here. So we combine all these 3 marked terms, equation 8 for the leading term, equation 7 for the second term, and the equation 9 for the very last term. It takes some effort to combine them. Then after we clean up, we get a relatively simple equation. And as you can tell, this is a Bessel of order 1/4. So we get this solution. u as a function of z equal to the combination of two Bessel equations of the first kind of order a quarter. Then this z has to be replaced by the original transformation rule. We replace by x a quarter of fourth root of x. So this is the final answer. This is the solution of the given equation 1. This concludes my discussion of this segment.